here we're going to calculate an instantaneous rate of change. So we know from previous lessons that the average rate of change is just the slope of a line between 2 points on a graph. The instantaneous rate of change is the slope of the tangent that touches the point on that, or touches a point on that graph. So yeah, that's called the tangent line. So in order to do this, first of all, from a graph, let's just go through this question. So the graph below shows a population growth since 2006. Find the instantaneous rate of change in 2008. This question might look similar. It's the same as the previous lesson. It's just for instantaneous rate of change now. So t equals 0 is 2006 as per the question. So this is 2006. That means this is 2007, 2008, 2009, right? So we need to find the instantaneous rate of change in 2008. And really, the only way to do this from a graph, if we're not given an equation or anything, is to sketch in a tangent line. And in order to sketch in a tangent line, really, I have a ruler here, see this? Really the easiest way is to grab a ruler and to sort of just find that point. So actually, let me just go to that point on the graph, 2008. So we're looking at that point right there, right? And we basically want to put that ruler down, touching that point, just touching the graph. Remember, picture there's like a snowboard around this graph. Where would the snowboard be pointing, right? So for example, that touches that point, but it's not tangent to that point, right? It goes through the graph. Same thing with this. This might look a little bit too steep. We want it just to go sort of in line with the graph there. Another way to think about it is if you were to zoom in really close to the graph, see how the line looks like a straight line here that sort of goes like that. We want to basically find out what the slope of that line is. So there's our ruler. And if we look, I can actually draw right along the ruler. Look at that. This is a new feature that I'm just trying out now. So the point is we got to try to find the slope of that line, and that's equal to the slope of the tangent or the rate of change of the graph at that point. There, I was able to get rid of the ruler. So in order to find the slope of that line, we basically just need to find the rise and the run, right? Because the instantaneous rate of change, IRC, is going to approximately equal the delta y, the change in the y, over the change in x of that line. Remember, this is approximation because it's just from a graph. That isn't the exact tangent, but something close to it. So let's look. So the change in y has gone from 0 to 400. So this rise is just 400. That's our delta y, or our change in y. And then our x has gone from 0.5 to 3.5. So that's gone up by 3. Right? I think so. 1, 2, 3. Yeah, that's right. So if we just plug those numbers into our graph, our delta y is going to be 400 divided by 3. This gives us a value of 400 divided by 3 is 133, approximately 133. Again, we need to include units here. So remember, the y part is population, so people basically, and the x part is years. So the unit for this is 133 people per year. I'm going to put ppl per year. Now, if you look, the answer to the question up here is 150 people per year. So maybe we didn't draw the line right on. It was a little bit off. It's just an approximation, but for this sake, it's a pretty close approximation to what the answer actually is. To get more accurate, we're going to need to start using the equations. And just to remember what this actually means, this means basically in 2008, the population was changing by 133 people per year. So basically, 133 people were coming into this town or being born in this town per year, right? And if we think about how that's changed over time, 2006 would have a tangent that looks something like this, right? So it's a little bit less steep. And 2009 would have a tangent that looks something like that. It's a little bit more steep. So we can say that the population is growing faster and faster as time goes by. So here's a problem where we're given a table and we're asked to find the instantaneous rate of change at t equals 2. So basically, what is the rate of change at this point, right? How fast is the population changing at that point? How are we going to do this? I'm going to start off with just a very quick sketch of what's happening here. If we look, this graph, it starts at 800. So if this is time and this is population, it looks like the time starts at 0 and the population is 800, and it's decreasing, right? So it's going to look something like that. Actually, let me just do that in blue. It's going to look something like that. I don't know exactly what it's going to look like, but in general, something like that. And we're asked to approximate the population at 2, right? So if I just zoom in there, we're asked to find basically what the change in population is at 2. So we're looking basically for the slope of that tangent line, which I've just sketched there. Now, the problem is we don't have too much information about this. How are we going to go about approximating this? And really the way to do it is to look what other data we're given. Look at what other data we're given. So we're not only given that the population at 2 is 652, but we're given what the population is at 1.5 minutes and 2.5 minutes, right? On either side of that. So if you think about it, if we wanted to find, if we wanted to approximate what that population is, so 2.5 would be something like here, right? And 1.5 would be something like there-ish, like there. So even if it's not exact, we could look at what the population is at 2.5, right? And if we connect those two, if we look at basically the secant between those two, it's going to be very close to the tangent, right? Alternatively, we could do the same thing with 1.5, right? We could find what the population is here. Well, we know what it is. It's given in the table. And look at this secant here. And that, again, is going to be very close to the slope of the tangent, right? Because those are the two closest points to it, this is something we can do. So to try to get as accurate as possible, that's essentially what we're going to do. We're going to find the slope of each of those segments. I'm going to call it M1 for slope of that little segment there, and M2, slope of that little segment there. And then we're going to compare them and see if that can help us approximate what the slope of the tangent is at that point, okay? So M1, the slope of M1, is going to be just our change in y over our change in x between these 2 points, right? So what's our change in y? It's gone from 737 to 652. So we're going to do y2 minus y1, so 737. Basically, we're using the average rate of change, right? 2 minus 1.5, right? And that gives us an M1, a slope 1 of that little segment of negative 170. And it's bacteria per minute, right? So let's do the same thing with M2, that second little segment there. And here, actually, you know what? I'm going to do it in blue, M2, because that is the difference between these two right here, right? So again, it's going to be delta y over delta x, change in y over the change in x. It's going to be 515 minus 652 over 2.5 minus 2. And this, if you do this in our calculator, will give us negative 274 bacteria per minute. Okay, so now we have the slope. Remember, let's go back here. We have the slope of M1, so it's this little segment here, right? And that is negative 170. And we have the slope of this little segment here, blue. We calculated in blue. So it's that little segment there is negative 274. So how does this approximate the slope of that tangent line? Well, maybe one way to do it is we know it's steep. The graph is steeper here, right, in this first segment right here, and it gets more steep here. So the slope of this tangent is probably going to be between those two slopes. So one way we can do this is to approximate it by finding the average of those two slopes. Okay? So we're gonna approximate the IRC is going to be approximately equal to the average of those two slopes. So the average, remember, we find it by adding those two things up, 170 plus negative 274, divided by how many things there are. So there's two of them that we're taking the average of. So we do this calculation, and we get negative 222 bacteria per minute. So this is one way from a table to approximate the instantaneous rate of change, just by looking at those little secants before and after, and then taking the average of them to find or to approximate the instantaneous rate of change. It's not going to be exact, probably. If we used a computer model to generate a curve and then find the tangent, it's probably not going to be exact, but it is close. And you'll see how we can do this a little bit more accurately in the next section when we're given an equation.